folks. Sorry about that. So our range ended up being y is greater than equal to 21 for this problem. So we're going to do a similar task for the next one, finding the domain and range of an absolute value function. So I'll go ahead and give you the gist here. An absolute value function, x can be anything. So the domain, of course, will be all real numbers for part B. But for the range, so we got the -3, absolute value of x, plus 5. Think about what this looks like, right? It's a B or an A. The negative does some dirty things to this because it makes it open down. What does that mean? It's going to have a max, not a min. Right, so we think about the graph. We think about, I can pull that up using the graph feature of my calculator. But what are we able to do? Sorry, I'm a little fidgety with these tops. These are new markers. Risked my life trying to get them in the snow. Anyways, x can be anything. That's kind of what the meaning of these arrows is, right? They go out forever, they go down forever. They go down forever from where? From this top point. Where is that top point? That's at 0, 5. So the domain we said was all real numbers, but the range is, of course, going to top out at 5. So y is going to be less than or equal to 5 for this one. Yay. All right. Hoping for battery power to finish this out. All right, let's see. That was number 10. So we're on 11. We got some circle stuff. Now, we didn't spend a whole lot of time, but it was there. And these had some very basic theorems. So, what is this? 11a. We had a circle and 2 chords. And the product of each piece of chord, that had to be equal. So what does that mean? 9 and 5 are on the same chord. 9 times 5. It's got to be equal to x times 15. Pretty simple, huh? I know those aren't fun to memorize, but that's the only way we have. So that's 45 equals 15x. X must be 3, right? Because you divide both sides by 15. Yeah, you got it. And then the letter B. Letter B introduces, I got to stand for this one, secants. Right, secants meet outside. So outside times the whole equals outside times the whole. We have 12, we have x. We have 8, we have 2. So what did I mean by that? Outside times the whole. Mumbo jumbo. That kind of makes me hungry. Outside is x, the whole would be x plus 12. So I have x times x plus 12 equals same kind of deal here. Outside is 2 times the whole, which is 2 plus 8, or 10. So I have x squared plus 12x equals 20. And oh no, I think I've done something wrong. But nonetheless, x squared plus 12x minus 20 would be our next step because it's quadratic, setting it equal to 0. It's going to be our only way to solve it. And here's why I said I think I've done something wrong. This is not going to give us a nice pretty answer. There are no factors of negative 20 that add up to 12, are there? You know, I think 10 and 2, right? Well, that's kind of what I was thinking, but I screwed that up pretty good, huh? So anyways, we'll go ahead and solve this nasty thing and see what we come up with. Probably not going to be a pretty number, but that's okay. We can deal with that because we have the quadratic formula. Oh, what a great time to review. So the quadratic formula works on the coefficients of the problem. Negative b plus or minus square root b squared minus 4ac all over 2a. So negative 12 plus or minus the square root of b squared, which would be 12 squared, or 144, minus 4 times 1 times negative 20. All of that's going to be over 2. So x equals negative 12 plus or minus the square root of 144 plus 80. What is that? 224, 224, all over 2. And for the sake of time, I am on limited battery and memory. There would only be one answer that applied here. It would, of course, be the positive answer because we're not going to have a negative value for x in this physically defined problem. And last but not least, sectors and arcs. So, big ticket item here at the end because I'm cool like that. Kind of cram a lot of stuff into one problem. Those are my favorite math problems. So remember, sector was like a piece of pizza, right? A section of a circle. So find the area of the sector in a circle with a radius of 10 using the angle 2 pi over 3. Right? That's in radians, right? How do we recognize it's in radians? It has pi. And not the good kind of pi. I like this pi. You probably don't like this pi. You should. Anyway, that's what goes around. Yeah. So anyways, how do we deal with sectors? The area is the whole circle, right? But then proportion based on how much out of 360 it works, right? We're going to just work in degrees. You can do it in radians. Got a feeling you don't want to. So what we're going to do is convert this to degrees. 2 pi over 3 can be converted to degrees by multiplying 180 over pi. Notice the pi's cancel, and I get 120 degrees. That's what's going to go here. And here's what I meant by proportioning. 120 out of 360 is simply a third. So this piece is basically, or actually literally, 1/3 of the circle. So all we're going to do is say the area of the circle, which is pi times 10 squared, times 1/3. Or more simply, 100 pi over 3. It's beautiful. I know it's beautiful. Right, don't go around in circles trying to get that answer. Think about 120 divided by 360, right? Last one. What arc length applies here? So we have a formula here. I don't believe you'll be given this on the test. Sorry. S is the arc length, which is this distance here. How long is that curvy thingy? R is radius. Theta is the angle in radians. So lucky you and me, the angle was given in radians. So all we've got to do is plug in R, which is 10, and leave the angle here as radians, 2 pi over 3, and we have our answer. I'm going to leave our answer in exact form. 20 pi over 3, right? Or basically, let's see, what is that? 6 2/3 pi. So we're looking at 20 something. Yeah, 20 something. A little over 20. You have the calculator, right? All right. Another thing to study, make sure you go back and you do the math 2 problems. Right? You're going to have another day off. It's just what it is. So make sure you go back and do those. There's an answer key that goes along with it. You're going to get it as long as you're signed up for a remind. And stay safe in the snow. I'll see you soon.